Thanks for taking the time to watch our Data Product Accelerator demo. I'm Glennon Clausen. I'm the Director of Engineering at Cavallo Technologies, and I'll be taking you through some of our tooling that enables building data products on Databricks. Maybe first, it's worth level setting with the definition. Our definition of a data product is a clearly defined, documented, and governed unit of data with clear ownership and usage characteristics, and it's usable for one or more downstream processes. From Microsoft, the data mesh approach adopts the concept of data as a product. Application owners and application teams treat data as a fully contained product that they're responsible for, rather than a byproduct of another team's process. Data products bundle together the ownership, the properties, and the governance of a piece of data to keep it within something that people can fit in their heads, something that people can deliver, and something that a team can own in isolation. It reduces the impact of maintenance on data because you can tell exactly where something failed. Sometimes a data warehouse is extremely large and there's large lineage and you don't necessarily know where something failed. Well, data products keep that validation close to the data itself. Usually this is one repository that contains a single data product, and the data product is governed by a data contract, which is something that I'll be showing in just a moment. Some characteristics from Microsoft: they're discoverable, understandable, and trustworthy. Most of that comes from that data contract, which is a clearly defined document that can programmatically check your data, but it's also something that syncs to Unity Catalog in Databricks. So if you are looking for new data to use, or you want to see what exactly is in this table, it's clearly defined and documented there, whether that's for AI looking for data or a human looking for data. It's addressable, natively accessible, and secure. Again, that's very well enabled by Unity Catalog. And with all of our accelerators, we deploy using service principals, and we secure using Entra ID groups. So everything is secure, governed, and auditable. It's also interoperable, truthful, and valuable. That is, it's going to provide some value downstream. It's not just a repeated copy of data. It's interoperable, as in we build it so that it's not tightly coupled to a single use case, especially if it's further left in the build. We want that to be usable for multiple downstream applications, and that also goes to that discoverability, so that you can discover things that have already been built and not rebuild them again. All of that is enabled by Data Product. I'll just quickly say Cavallo Technologies is a data and AI company. We have a substantial data engineering team. I oversee about 35 data engineers as of today. We have an AI and analytics team with expertise in both traditional and generative ML and several use cases in production, which I think is especially worthy of celebrating given how few use cases get to production in AI. We have a cybersecurity and infrastructure team with dozens of years of banking experience, regulated industries experience, and a growing financial crimes compliance team. We have a lot of Databricks certifications, top 5 in Canada, and several domain expertises as well. But maybe I'll just continue talking about the data product accelerator. So all of our accelerators, data product included, have a consistent foundation with environment deployment, CI/CD, a predefined software development lifecycle. Of course, we can adopt that to whatever a client has on their own, and a predefined code structure so that people are not thinking about those things as they build. We speed time to value by providing one or more working production-ready sample implementations. And so for the data product accelerator, the sample implementation is some data products based on cell tower info. It's just generated data. And some features that has it. One of the things it does is it takes the content of a data contract, which is a YAML document defining the data, and it syncs that up with Unity Catalog. That's not something that Databricks has natively, and so we built that in. It also exports the data contract in formats that are usable by the business or by other pieces of software, or if you want to put them in your Jira or GitHub documentation as Markdown, that's just automatically part of it. And maybe most importantly is automated contract testing. So when you define a data contract, automatically tests are generated and on every deployment run against your data product to validate that it is in fact meeting the requirements of its contract. But rather than just talking about it, maybe I'll just show you what this looks like. So here I've got the YAML for a data contract specification. This is in our data contract accelerator repo. And it says things about who owns this data, where it came from, what it does, where you can find it, what kind of servers. Terms of use, retention, freshness, latency are all things that you define in there so that someone knows how frequently this is going to be updated. For example, when is this data from? And then maybe the core component is these models. So a model translates to a table in Databricks, and we have one for cell tower sessions and one for signal strength summary. So this is the initial document that that we create to govern our data, and then it goes from here to our development team or your development team to build out, well, how do I create a data product for cell tower sessions? So it's got things like field definitions, examples, flags as to whether it's required, unique, descriptions of the fields, and then it even also has quality checks per field. So things like users should not have more than 500 devices. And here is a SQL query that would define that. This is run automatically on every deployment to validate that this remains true. So you have programmatic guarantees on your data contract. This document gets updated, and then we build Databricks workflows in order to satisfy this contract. And the final product that you get looks a little bit like this. This is the cellular domain. You'll see that it's tagged properly with an owner and an environment. Now you can see bronze, quality, and silver here. That's because I'm an account admin on this account. Normally, users would not see these. They kind of hide under the surface, under the hood of the car, and you would just see the data product itself, which is usage info. So I'll click into that. You'll notice here, these descriptions are automatically synced from the data contract that we wrote. It has tags to indicate not just the lineage of the data, which is something that Databricks shows in lineage, but also the lineage of the code that built this data product so that you know where what you're looking at came from. So here's the repo, here's the tag that deployed this, and we have our two data products here. If I click into signal strength summary, you will see some descriptions, and I'll just prove to you these are synced over from the data contract automatically using our tooling. We've got proper types on here. You'll notice that this is deployed using a service principal because, like I said, everything we do is via service principal and proper Entra ID groups. And yeah, so this is the deployed data product. So how do we get from a data contract to the data product? That's defined in these pipelines that are created. We use a combination of Lakeflow declarative pipelines and just normal Spark jobs to build these. So I'm going to dig into the production pipeline here. There's a few interesting things in here. A lot of this is just related to generating some of the sample data for the data product, so less interesting. I will note that we have a bunch of reference implementations here so that when your staff or our staff are getting started, there's a clear known working example of how to build some things. Notably, the Spark for data source API just came out, so we have some tooling for streaming data from APIs that fits natively with Spark structured streaming. There's an example of that. We also have tooling for benchmarking workloads. Sometimes when we work with clients, they want to test a few different types of compute or a few different ways of doing one specific thing. This allows us to benchmark how much that costs and how long it takes so that we can make the right choice for which tool and with which method to use for the client. I think maybe most interesting here, we get some data, we transform it with Lakeflow declarative pipelines, and then we test it. And I really like this page, especially the visualization. I'll just get to the bottom here. You can see that these tests are not written anywhere explicitly in our repository. These are generated based on the data contract itself. So every one of these is checked against the tables that are deployed. Things like correct field types, minimums, maximums, whether something is part of a correct enum. All of these are tested every time the code is deployed through the various environments to validate that what you're deploying meets the business standards. We strongly encourage that when you write a data contract, you do so in collaboration with the business. Take those things that the business is telling you need to be true about your data and turn them into programmatic checks. That's going to help that unit of data become effectively governed and trustworthy for downstream sources to then use it. We also leverage lakehouse monitoring and deploy that automatically to watch for things like data drift, things that you might not be able to programmatically check, but things that might change over time, such as, is my user base increasing at a rate that I would not expect? Maybe we should alert me on that. And then we have several other reference implementations, again, to speed up clients using things like Spark structured streaming, Lakeflow declarative pipelines, and jobs. All of this is deployed using Databricks asset bundles. All of this is deployed using CI/CD with GitHub Actions. And like I said, it's all secured using Unity Catalog, which syncs from Entra ID with proper groupings. This accelerator pairs particularly well with our infrastructure accelerator, which accelerates the deployment of production-ready, regulated industry-ready templates for workspaces, virtual networking, and storage security. So thank you for taking the time to look over this accelerator demo. If you are interested to hear more about our services or about our accelerators, please reach out to info@cavallotechnologies.ca or myself on LinkedIn, and we'd be happy to chat some more. Thank you for your time.